Okay, let's talk about code execution. I'm going to show you code execution two different ways. We're going to do it first using built-in commands in Windows, and then I'm going to show you Beacon's automation to do it without touching disk. But let's start by doing it the native way. Here's the four-step process to get code execution on a Windows system. Okay? Step one, establish a trust relationship with the target. I showed you how to do that with stealing tokens, making tokens with credentials, pass the hash, and how to ingest Kerberos tickets as well. Next, you're going to want to generate an artifact and copy it over to the target. Okay? Next, you're going to want to run that artifact on the target. And finally, you're going to want to assume control of that artifact. Let's go through these steps. First, to generate an executable. For your lateral movement needs, I really recommend using the SMB beacon. That's the beacon that you can use to chain beacons together so they egress through a parent beacon. SMB beacon is phenomenal for lateral movement. So just go to Text, Packages, Windows Executable to export a stageless SMB beacon in a wide variety of formats. Now, to copy that executable you export, just use the upload command to upload the file you generated to the pivot host and copy that uploaded file over to the target using the copy command available in the shell. Not too scary so far, right? Now let's talk about a couple of different ways we can use to run this executable. One of my favorite options is to create a service. This method requires that the executable you generate is a service executable. So pay very close attention to that because a plain executable will not run properly. So once you copy a service executable over to the target, all you need to do is create a service that references the executable you copied. So just do shell sc // target, create name, bin path equal. Very important, don't forget a space. C:\Windows, temp, wherever you put the executable. Okay? Now, you can go ahead and start the service on target host with just sc // target, start, and the service name. Very cool. And if you want to clean that up, just do sc // target, delete, and the service name. That's how you kick off an executable using the Service Control Manager in Windows. Okay, let's do some lateral movement. Here we are in the JSmith beacon. No special trust. I got rid of all the stuff we did previously. We know from our previous efforts that JSmith is a local administrator on the file server. So let's just do a dir on the file server to verify that. Pretty cool. Okay, cool. So let's go ahead and take the file server. Let's first export a stageless Windows executable with the SMB beacon in it, and we'll do a Windows service executable. We'll call it lateral.exe. Next, let's go to a folder we know we can write to, JSmith downloads. And let's go ahead and upload our lateral.exe and copy it over to the target. Okay? So all we're going to do is copy lateral.exe over to the file server, C Windows temp. Okay? Let's go ahead and create a service on the file server to run our lateral.exe. So we'll just do create lateral bin path equals C Windows temp lateral.exe. And let's go ahead and start the lateral service. We're just waiting for an acknowledgement that our service was indeed created for us. So that might take a moment. There we go. Let's go ahead and start up the service. Now, when I'm doing pivoting in this way, moving around a network and chaining beacons together, it's definitely my preference to live here in the pivot graph. So this is where we're going to be. So now we're waiting for acknowledgement that our service was started. So let's go ahead and link to the file server and assume control of that beacon that is running there. And there we go. We've now taken the file server by doing our lateral movement by hand. Last step, let's just go ahead and clean up. Let's delete lateral.exe off this system. And unless we're going to use it again on the other target, good idea to delete it off the other target too. So let's just do a dir or del c windows temp lateral.exe. We can do this cleanup because beacon service executables, or excuse me, Cobalt Strike's service executables automatically migrate for us. So all we're doing is deleting that file and getting rid of our service as well. Cleaning up is definitely good tradecraft and good professionalism as well. Let's go through another technique. This one uses @. To use @ to run an executable, first generate a Windows executable, plain executable, and upload it to the target and know where it's at. And then next, find out the time on the target system. Just do net time whack whack target. Next, use @ to ask your executable to run in the future. Just do @ back whack target, tell it a time in the future relative to the target, and the path to the executable on the target. Okay, presumably we've gone as far as we can with JSmith, so let's use @ to try to take the DC from the file server. Let's interact with this beacon and do a PS and see if there are any processes running as interesting users. And looks pretty cool. Explorer.exe. Let's go ahead and steal a token from that process. And we've now impersonated the administrator user, the domain administrator. Let's verify that we can hit the DC. And the answer is yes, we can. Cool. All right, let's go ahead and use @ to push an executable over. First, let's generate that executable. Windows executable stageless. We'll do an SMB beacon as a plain Windows executable, and we'll call it demo.exe. Why not? And let's go to cd c windows temp, upload demo.exe, and let's copy demo.exe, not to the file server, but instead over to the domain controller. Let's do a net time on the domain controller. And let's schedule our executable to run at 10:55 p.m. So C Windows temp, demo.exe. So we've added a new job to that system. And now we've got to kill about a good 40 seconds or so until the job actually kicks off. Okay, let's do a net time again. And we can see that our job did kick off, probably. So let's go ahead and link to the DC. And there we go. We just took the DC with an @ job. So that's an example of lateral movement with @. Okay, let's talk about beacons automation. The downside to the previous two approaches is that they require you to put something on disk. And most red teams I work with are rather allergic to the whole concept. Okay? So Beacon has automation to help. First, you can use psexec in Beacon. Just type psexec target, a share, like $, admin$, and a listener name. And Beacon will generate a service executable, copy it over to that share, create a service to run it, stop that service, delete it, and clean up the executable. Okay? I put this old school psexec in place for situations where you're dealing with Windows XP systems. Beacon does have PSExec PowerShell, and this will create a service that runs a PowerShell one-liner that gets your payload stager into memory. Okay? PSExec PowerShell is pretty nice. It doesn't touch disk. That's pretty handy. The downside to services, of course, is it does create a log entry with the command that was run. You can use WinRM to kick off a PowerShell one-liner. Just do WinRM, the target name, and the listener you want to run, and Beacon will attempt to spread laterally that way. And you can do WMI, the target, and a listener, and Beacon will try to use WMI to kick off a PowerShell one-liner on a remote host as well. Okay? The WinRM and WMI options do not touch disk either. Now, one thing to note about WinRM and WMI is you will be in a restricted token. You'll be running as the user whose trust relationship got you onto that system. Okay? But if you try to interact with another system from that new system you've gained, from that access token, it will not work. This is called the double hop problem. It's well understood by Windows administrators. The solution to it is to use make token to create a new token on the new system, or inject Beacon into another process. Now let's go a little bit further with Beacon's automation. I've shown you how to do a lot of things by hand. Beacon does have automation to put all of this together for you. If you go to Cobalt Strike's target view, you can right-click on a host and go to Login, choose your favorite method, and you get a nice dialog that looks like this. Okay? You can choose credentials, either hashes or credentials, and you can pick a listener and pick a session. And what Cobalt Strike will do is it will set up the trust with those credentials or that password hash, and it will use the lateral movement technique you selected to execute whatever Beacon payload you requested on that target. And it will do that from the session you selected. If you don't want to create a new token, just check the box that says Use Current Session's Access Token. That's fine as well. Okay, now that I've shown you how to do lateral movement by hand, let's try it out with Beacon's automation. Here we are in a new network with a new foothold, one that's a little bit bigger, although I will caution you, it is an older test lab, but the benefit is it's bigger. So let's go over to the targets view, and let's go to What a Hog, Explore, and run NetView to find out some of the targets available to us. Okay, and there we go. Now that's not a bad start. Now let's get the help of a little bit of automation to find out where we might be a local admin. So let's go to PowerView, PowerView PS1, PowerShell, invoke, find local admin access. Okay. So away we go with PowerShell, looking for where on these systems we might be a local admin. And that's going to be our first jumping point. And there we go. We have our winner, and that is the file server. So let's try to take over the file server. Let's just go right click, login. We'll do PSExec because this is a older system. You can see by the icon. Let's do PSExec, and we're going to deliver the SMB beacon. We need to choose a session to work from, and there's only one right now, so hit choose. And we're not going to use any creds or hashes right now. We're just going to use the session's current token. Hit launch, and that will launch Beacon's PSExec against target. And there we go. We've now taken over the file server, and we have a beacon running as system. Okay? Let's go to Explore, Process List, and see what might be running as whom. Sort by name, and we see administrators logged in. Pretty cool, right? Let's go ahead and steal that token. And presumably, this beacon now has an administrator token. So let's go ahead and try to take a few more boxes. And by a few more boxes, I mean everything else. So let's just go ahead and push Control-Alt, highlight the systems we want, go login. We'll just do psexec since we're dealing with a mix of operating systems here. And what we're going to do is SMB beacon, choose the session to fire from, and that's the file server here because it has the token we want. Hit choose, and we're going to use that session's current access token, hit launch, and there we go. We've just launched Beacon's or Cobalt Strike's automation against those different targets. And in a few moments here, we should start seeing accesses come in. Okay? Cool. Now, if you want to know what this looks like, jump over to the handy pivot graph, and now you can see what our access into this network looks like. Okay? Layout tree top. There's our foothold. There's the first system we took, and then there's the other systems we were able to take from there. Okay, that was a lot of material, but you gotta admit, it's pretty cool stuff. We talked about the Windows Enterprise. I took you through host and user enumeration. We talked about how to interrogate and control a system without malware. I took you through how to set up trust relationships by stealing tokens, using credentials, using password hashes, and ingesting Kerberos tickets. I also showed you a few ways to get remote code execution using Beacon. This concludes part 6 of Advanced Threat Tactics.